Hello everyone. I would like to deliver a presentation about our project, Hackathon project with the title Forest Fire Detection and Preventions in Indonesia, presented by Resyst. Resyst is a group of engineer and scientists. Okay, the next slide. The outline of this presentation will be, the first is we'll talk about the main problem of and the current stations of the forest fire in Indonesia, and when it comes to the proposed solutions for mentioned problems, and we will talk about the detailed solutions, and the last is the conclusions of what is the actual problem that we have faced here for the forest fire in Indonesia. Actually, the fact that for years the forest fire relatively increasing due to utilizations of the forest and global warming, and of course it's causing so many victims due to forest fires for the last 10 years. Surely the specific problem that we can narrowing here, first is the fire cannot be detected early, and usually the forest fire detected when it's already widespread. And the fact that we found again that number of forest fire is relatively higher in every years. And the third is the recovery and restoration costs damaging our country economic here. So the solution to overcome this problem is by using the artificial intelligence, or AI, and Internet of Things Edge. So what do we want to do with the artificial intelligence? We want the AI learn how to detect the fire in the forest. By of course we want to train our AI by using a supervised method, and by training them with a high quality image, we want also to produce and deploy high trained model of AI, and then those model will be embedded in the IoT Edge. The IoT Edge is the sensor node that capable to run in some AI algorithm or deep learning algorithm, and from the IoT Edge will perform the detections and report the data to our cloud. Okay, so what is the AI algorithm or deep learning algorithm that we propose in this hackathon? We want to use convolutional neural network that can be mobile VNet 2 or YOLO. Okay, this is the flow diagram of how to training or how to perform data training to get our final model of our AI. First is we need to preparing the data set, since we are using the supervised learning. Of course, we need to separate the image with forest fire and image with that contain no forest fire. We split this image into two kind of image, and then we train the fire detection using convolutional neural network. And after that, of course, we need to see if our trained image or our trained model is good enough. And then after that, we deploy our model to the IoT Edge. After we train our model, we have a good result of the model. Then we need to load the model into the IoT Edge device. The IoT Edge device will use our model to perform the fire detections in the image, and then we'll send the report or the conclusions of or the predictions of image detections in our IoT Edge. So what is the meaning of IoT Edge? Here, the IoT Edge is the IoT sensor node to perform image detections. So what is the ideal IoT Edge? The ideal IoT Edge usually have specifications. Those are ultra low power, usually using microcontrollers, and having high communication data rate, and the IoT Edge also secure and reliable and have high performance. Usually we have there is no ideal IoT Edge, such term in the market. We have usually need to trade between low power and high performance. We also need to trade between high data rate and high data rate and the range. So what is best candidate of IoT Edge that will fulfill the needs of our experiment here? That is CPIT, make speed with specification RISC-V dual core 64-bit, support microvisions. It has also tiny machine learning library inside the firmware, support also TensorFlow Lite, and this hardware or this device also support camera, and it's not high cost. That I think it has middle cost about $30. So we comes to the hardware diagram. I try to simulate the situations of our final IoT Edge. The sensor node will be powered with a solar panel, and the solar panel will be usually attached at the outside of the box or outside of the enclosure. Solar panel will charge the battery inside the box for our sensor node. Then this battery will power all of the hardware inside or in the board of sensor node. So I try to create our sketch here. The IoT Edge will need single PCB to operate, and on that single PCB there will be 4G modem to perform communications to our cloud. And the second is the sensor. This sensor will perform like temperature measurement, humidity measurements, and smoke detection and smoke measurements. And here the IoT Edge block, we will put our IoT Edge device there, and then all of the boards will be supplied by a single power supply from the battery and the solar panel. If we take a look at the bottom of our PCB, will be put some of battery that capable to perform up to 10,000 milliampere hour. And here are our specifications. This sensor IoT Edge will be powered with solar and battery, and it has enclosure IP67, which has capability of dust proof and waterproof. And the PCB will be built on the 4-layer high quality PCB and battery up to 10,000 milliampere hour. So the next slide, what would be the uploaded data to our platform? So the data that will be uploaded to our cloud will be, first is the image detection result. For example, in that picture, what is the probability of fire detected in that our captured image will be sent into the cloud, for example 92%. And then in the pilot also we include the sensor failure measurements, for example temperature, humidity, and the smoke detections. And if necessary, we will upload the image. For example, when the situations getting worse, that when the fire detections, the image of the current situation will be uploaded into our cloud, into our platform, and will be analyzed manually, and then will be performed a next step. And the other step is that we want to send to our cloud is connections of the sensor node. And the important one is the battery status. The next slide will explain the functions of the balloon repeater. This balloon repeater will act as repeater to strengthen the Wi-Fi signal and 4G signal connection in our IoT Edge area. And this balloon also provides fire location detection and real-time situations monitoring. And finally, in this slide, it will show the system diagram of our system, where the sensor node will send their data through Wi-Fi or 4G as the backup, and we'll send it to the repeater first, and the repeater will forward our data to the cloud, and from the cloud we can monitoring the data and can be accessed by multiple user, and hopefully we also can provide the interface for the user. Okay, that's all of our presentation, and thank you for your attention.